Welcome to this lesson on blockchain basics. And in this lesson, we're going to just take a brief look at what is a blockchain and how it works at a very high level. So the first question is, of course, what is a blockchain? Now, the best way to think of it initially at this level, at a very basic level, is that it's essentially just a database. And the important thing about this database is that it has specific properties that make it a blockchain. One of these properties is that the data structure is a linked list. And the linked list is essentially a collection of blocks that contain transactions. And the transactions depict the change of state of the blockchain. We're going to dive deeper into that later. For now, I just want to keep the definitions at a very high level so that you can get started. The other thing that you might hear blockchains being referred to is as a distributed ledger. This is because essentially, because the blockchain contains a list of transactions, that is known as a ledger. And it's distributed because blockchain databases are decentralized and form a network of nodes and peers who all contain a copy of the database. And again, this is something we're going to dive into later when we look at the architecture. But for now, these are some of the high-level definitions. Now, we talked about blocks. So what are blocks? Well, as mentioned before, the blocks contain transactions. Transactions are submitted to a blockchain, and they are ordered by timestamp and by other factors, as we'll get into later, such as price, and then they are grouped together into blocks. Once the block is full of transactions, again, what denotes full is something we cover later, the block at that point is then hashed using a hashing algorithm, and then the hash of that block is then used as a reference that the next block will link back to. So it's probably better to look at a diagram to understand and get an overview of what a blockchain database looks like. So here in this diagram, I am showing you a blockchain at a very high level. And as mentioned before, blockchain structure is essentially a linked list of blocks. And so if we start with this block here, we can see that the block contains a list of transactions, as mentioned before, and once the block is ready to be sealed, it is hashed. This hash value here is then used in this block, so it's placed into this block along with the transactions that go into this block, and then this is hashed. So the combined data of the previous hash plus the transactions in this block are then hashed to generate a new hash. And then this hash is placed into this block together with the transactions that go into this block, and then that is hashed, and so on and so forth, creating this chain of blocks that are linked together cryptographically using these hash values. Now, this structure, which is fairly simple at a high level, creates some very powerful properties of blockchain databases. And one of the most important properties that it generates is the property of immutability. This means that if you change data in any of the blocks in a blockchain, that block will immediately be invalid. This is because the data in the block no longer represents the hash that was generated when the block was mined. And so that clearly means that the data in this block is invalid. But the important and powerful concept behind this is that because the blocks are linked together, all future blocks are also rendered invalid. So as you can see here, all the blocks to the right of the block that has had the data changed are now no longer valid. Even if this block's data hasn't changed, it's no longer valid because it's cryptographically linked to the hash of this block. And now this hash is invalid. So I hope that's clear. And if this blockchain diagram continued on, to the right of this page, then they would all be invalid. Note, of course, that the blocks preceding the invalid block are still valid. So if this kind of thing happens, you might have a fork in the blockchain, or at the very least, these submitted blocks would not be accepted by the peers because they would validate them and say they are invalid. Now, in future lessons, we will go through a hands-on exercise where we see this happening in action, and you can change data and see how the block becomes invalid and future blocks become invalid. So that's something to look forward to. And the final thing I want to cover in this brief lesson on blockchain is the concept of block numbers. You can think of a block number as essentially an index of the block in the blockchain. So the very first block is block number 1, the second is block number 2, the third is block number 3, and so on all the way up the chain until you get to block n. Block n is the head of the chain, and sometimes you can get that through a function that will give you the head block number or the latest block in some APIs. And you can also get blocks by number and inspect transactions within the blocks. Now, one important thing to note about the blocks is the first block is sometimes referred to as a genesis block. And the important property of a genesis block is that it does not have a preceding block. So it does not have a link going back, because this is essentially the tail of the linked list, and therefore it doesn't have any link going back. So that's what I wanted to cover today with the block numbers and with the introduction to blockchain. And in this lesson, I hope that you got a sense of what blockchain is and what the properties are and what makes blockchain immutable and powerful. But there's much more to go, and we can dive a lot deeper into these topics in later lessons. The next lesson, we're going to go into a demo where we can actually hands-on try out different blocks and change data in the blocks, see how the hashing function changes, and see how we can invalidate blocks and how that works. So this will be in our next lesson, so I'll see you there.